solar thermal and photovoltaics. We would be addressing only photovoltaics, which garners energy from photons rather than thermal energy. Photovoltaics are the most common type of solar energy employed today. Solar energy works through the employment of photovoltaic cells as well as the photoelectric effect. A solar panel is composed of a reflective shield for the purpose of capturing as much sunlight as possible. Then, a negative conductor below assists in the movement of electrons. Below this is a semiconductor, usually silicon. Finally, there is a positive conductor below the semiconductor that also allows electrons to flow. The mechanism that allows solar photovoltaics to work is pretty simple. Photons of light are absorbed by a material and this causes electrons to be released. Giving these electrons a pathway to move allows us to store or use the energy. Currently, solar energy is not competitive with non-renewable sources in efficiency.
Application for solar energy is placing solar panels on buildings to power cities. Another application would be placing solar panels in open fields to bring power to remote towns and even villages anywhere on Earth.
There are a couple of ways to optimize solar energy in the United States. One way is to determine areas with high photovoltaic resources. These resources are mostly concentrated in the southwestern portions of the United States, spreading out into the western and southern portions. Another way is the introduction of the solar tracking systems. Though in development, these systems help solar panels to track the sunlight throughout the day as it crosses the sky. Collectively, they can increase output from 27 to 40%. There are two types of systems. There is the single axis and there is the dual axis.
Economic incentives exist for individual consumers who choose to outfit their homes with solar cells. The average cost of electricity in the United States is 10 cents per kilowatt hour, but solar and battery storage could cost as low as 5.5 cents by 2030 with existing technology. This represents a vast price drop from current U.S. energy. Solar's transition to a major player in the energy sector will occur naturally as its price falls. In many places, it is already cheaper per kilowatt hour than existing energy systems. While natural disasters have devastating effects, they present a unique opportunity to redesign and retool energy systems. The recent hurricanes that struck Puerto Rico, Florida, and Texas all left massive damage to power grids in their wake. Each of these areas has high photovoltaic potential, meaning they see a moderate to high amount of the sun's energy compared to other territories. Rather than repairing destroyed systems, the better long-term investment in the aftermath of a disaster could be replacement with solar cells.
Center for Renewable Energy Research, the National Renewable Energy Laboratory, the U.S. Department of Energy, and numerous other organizations are all conducting research on solar energy. They are all looking for ways to improve the efficiency and cut the cost of solar panels.